we're going to take a look at solving linear inequalities. And specifically, we'll be looking at what similarities and differences are there between equations and inequalities when graphing. And we'll be using our skills of graphing equations so that we can graph inequalities. But let's kind of go through and remind ourselves what an inequality is. We know that this sign here, that's the less than sign, and this is the greater than sign. And when we graphed in one variable, we would use an open circle on a number line to show that we used less than or greater than. And the same as this is less than or equal to, and this is greater than or equal to. And just like we did on a number line, we would use a closed circle to show that it included that line. Well, what we're going to do differently is this. We are going to use a line because we're talking about a linear equation, which will be on, when we graph it, an equation we graph on a coordinate plane. The same is true for an inequality. So when we're talking about less than or greater than, we are going to use a dotted line. When we're talking about less than or equal to or greater than or equal to, we will use a solid line. So that'll be our differences when we're graphing in two variables as opposed to one variable. So let's remind ourselves that a line represents all the solutions to an equation. So when we're talking about lines, and lines reflect what we feel, what exactly happens with an equation, we see it represent all the possible ordered pairs that are involved. Now, because we're dealing with inequalities, we're going to have to add another dimension to it. We're going to have to involve what we call shading. Shading will help us to show that there are more than one answer. There are more than one answer for it to be true. In equations, we know that only one answer will make it true. In inequalities, we have more than one, and because we have more than one answer, we need to get some shading involved. And depending on whether it is less than or greater than, that will decide our side of shading, which side of the line we will shade, whether we shade above the line or we shade below the line. Okay, so first let's take a look though at just the basic idea of whether something is in the region that we are looking for. And we're going to take a look at an ordered pair and whether it is a solution for this particular inequality, x plus y is less than 4. We know that x and y is represented by 2 and 1, so we'll just substitute it in and reduce it down, and we end up with 3 is less than 4. We know that that is true. 3 is less than 4. So since this ordered pair provides us a true solution for this linear inequality, we know that, yes, this is a solution for that particular linear inequality. We'll do it one more time. We'll take the numbers 4, 8, and again, we know that that represents x, y in our ordered pair, and we're going to test it to see if it's a solution in the inequality of y is greater than 2x plus 1. So here I will have 8 is greater than 2 times 4 plus 1. We simplify it down, and we find out that 8 is greater than 9. Well, we know that that's not true, that that's false. And because that is false, that means this is not a solution to this linear inequality. It is not in the region that we are looking for. So now let's take a look at doing it from top to bottom, graphing and showing all the possible solutions to a linear inequality. So first off, we're going to remind ourselves some things. Y equals mx plus b. This is the slope-intercept form of an equation. I should say slope y-intercept form, because we can get, when it's in this order, when the y is on the left and everything else is on the right, the coefficient of the x term is the slope, and the b represents the y-intercept. Now, we know we can use this information to help us in order to graph. So since it's in the right order, let's just take information down. The slope of this line happens to be 1, and the y-intercept happens to be -1. And again, since slope is rise over run, we're going to show it as a fraction. We're going to put that information on this graph, so we'll start at -1, and then we'll rise 1 and run 1, and we'll put a few points on here so it'll help us to easier to draw our graph. So now we have to remember some things about inequalities. We have to remember If it is a greater than or less than sign, we will have a dotted line. If it doesn't, if it has that solid underneath it, that equal sign, we are going to make it a solid line. So because in our situation here, we do not have that equal sign, we're going to make a dotted line. So we're going to take a dotted arrow through our points here. Line that up carefully. So that's our first part. That's our boundary line pretty much, is what's going on here, is that sets up our boundary. Now we have to decide which way we're going to shade. Now, here's my little shortcut, and I find that this helps out a lot, that if we have a less than sign, we're going to shade below the line. In other words, we're looking for less than the y-intercept. If it's greater than, we're going to go above the line, or greater than the y-intercept. So since we have a greater than sign, we want to be greater than 1, -1 on the y-axis. So here's -1, and all the numbers on the y-axis greater than 1 are up here, going up this direction. So that's what we're going to do, is shade all of that in, and that's a great, fast, and easy way to show our shading. Now, remember that you must shade all the way across. Make sure you draw your lines so that they extend all the way through the coordinate plane. Don't draw a short line. Some people do that. And what happens when you draw a short line, you are not showing all the possibilities for inclusion. So make sure that you are drawing your line through the plane and that you're shading from one end to the other, just not part of it. So let's talk about shading a little bit more. There's two ways to test shading, and one is the one I just talked about right now. If you have less than, shade below the line, and if you have greater than, shade above the line. And what I mean by below the line or above the line, I'm talking about in reference to the y-intercept. Okay, look at the y-intercept and decide from there exactly what's happening. Okay, then the other way is what we call the zero test. And this is also a great way to test and see if a particular solution is a solution. Kind of what we just did in examples 1 and 2. What we would do is we would plug in and test if it is a solution. If it is a solution, we would shade the side of the line that contained the point. So in other words, it would include it. So we would shade it. So this would be a true situation. If it's not, we would shade the line that does not contain the point. This is a false solution. So let's go back a moment and take a look at the problem we just did and see and test the 0, 0. So let me get rid of this here so that we have everything with us. Move this over a little bit. Let's take a look at this inequality. Y is greater than x minus 1. And let's put the point 0, 0 into this to see what happens. 0 is greater than 0 minus 1. 0 is greater than -1. Well, we know that that's true. Well, if that's true, that means that the point 0, 0 is part of the solution. And if we look over on our graph, we see 0, 0 is on the shaded side. So we would include it in our graph. All right, so let's take a look at a couple problems and test this one more time. So let's solve by graphing 2x plus y is less than or equal to 4. Well, the problem with this one is it's not set up in slope-intercept form for us. Remember, we want to get the y by itself and mx and b on the other side. So in other words, the x term and the constant term onto the other side. One of the things we have to remember when we're moving things around like this is the rule for inequalities. Remember, if we end up dividing or multiplying through by a negative number, we must flip that inequality over. So please don't forget that. All right, first thing we're going to do is we're going to subtract 2x from both sides. Subtracting 2x does not flip the sign over. So we're going to end up with y is less than or equal to -2x plus 4. So now we're in the right format. We can get some information. The slope of this line is -2. We can see it right there as the coefficient of the x. And since it's rise over run, we'll put it over 1. The y-intercept, which is located right here, is positive 4. So that's where we begin. We begin at 4. B kind of helps us to remind us where to begin. So we're going to start here and put a dot at 4. From there, we're going to move. We're going to have a rise over run. We're going to rise -2, which is really going down -2, and then to the right 1, positive 1. So go down 2 into the right 1, down 2 into the right 1. And so now we have lined up. Now, what we have to go back is look at our inequality, and we see that we have a less than or equal to sign. So we need to draw a solid line through those points. Remember to extend your line into both directions and to make sure that you're putting arrowheads on both ends. I'm sorry about that. Let me see if I can fix this one here. Make sure I get arrows on both ends. And now we have to concern ourselves with shading. Well, since this is less than, we look at our finished product, not what we start with, but what we end with. Because if we decide to multiply through or divide through by a negative number, it will flip the sign over. So we have to keep that in mind. So let's take a look at our y test, which said, hey, we're going to go above or below the line. Well, this says less than 4. Well, all the y-intercepts less than 4 are below the line. So we can shade in this direction. Again, we can test the 0, 0 test, and we can say 0 is less than or equal to negative 2 times 0 plus 4. 0 is less than or equal to 0 plus 4, or 0 is less than or equal to 4, and we know that is true as well. So that means that 0, 0, this point right here in the middle, this needs to be included, and it is in the shaded region. Okay, let's take a look at something a little bit different. We're going to solve by graphing x is greater than or equal to 2. Well, this time, there is no y, so we cannot put it in slope-intercept form. So we have to remember some things about graphing. If there is no y in the inequality or equation, that means that line is not going to be touching the y-axis. It is only touching the x-axis because it only has an x showing. Well, since it's only touching the x-axis, this number here is telling us where it's touching it at. It is touching it at the number 2. So that means that we are going to draw a vertical line, and this vertical line is going to go up and down through 2, and we're going to make it pretty tall here. Give it some color. Boom, just like that. And remember to extend it high and low. So now we have to think about it. We want numbers larger than or equal to 2. Well, since we know numbers larger than 2, those would be 3, 4, 5, 6, and 7. Those would be found over to the right side. And we want to make sure that we are shading both top and bottom all the way through. Okay, one more problem to look at. Let's do it backwards. Let's take a look at an inequality, and let's write inequality based on the particular graph. Again, we know we're going to set up the structure of y equals mx plus b, and we can do that because we're going to use both x and y, because we can see that this is crossing not only the y-axis but the x-axis as well. So since we're crossing both of those, we want to be able to use it. Next we want to do is to take a look and see what information we can put. Well, since we see that the y-intercept is 1, we can replace that with a plus 1. We've got to figure out a slope, so we look for another place for where the line crosses, and we start to count our rise over run. 1, 2, 3, so we have a rise of 3, 1, 2, 3, 4, and we have a run of positive 4. So our slope is 3/4. So now at this point, we've got the right side of the equation, or inequality, 3/4 x plus 1. We know that y is going to be on the left side. We just have to decide what our inequality sign is going to be. Well, since there is a dotted line running all the way through it, that tells us that we do not have an equal sign, that we need to either have greater than or less than. And since we're shading above the line, we want greater than. So there's how to take a graph and write an inequality about a graph. I'd like to share with you also this website, http://www.shodor.org. There's some great interactive activities, and this particular location will give you the location of where you could go and try and plug in some different inequalities and see what the graphs are and how the graphs will turn out and how that all relates.